Hello everyone, hope you're doing really good and welcome back to my channel. Today we are at the day 8 of the daily Leetcode challenge of for July, and we have a hard level question in front of us. It's totally different from what we have in the previous few days, in the first 7 days, I can say. Let's see what the question is. It's question 2551. Put marbles in bags. Okay. So what we have is, as you can see here, the inputs first. We have a weights array which has a integer of arrays. Sorry, which array of integers and no integer k. Okay. Let's see the question. So we have k bags. So k is the number given here. So we have k bags basically. So in this case, we have two bags. We are given a zero index array called weights, where weight of I is the weight of the ith marble. Okay. So this is my number of bags we have, and here each of them represents the weight of the marble. Okay. This is the weight of the zeroth marble. This is the weight of the second marble, and so on. Okay. We are also given integer k. Okay. And divide the marbles into k bags according to the following rules. So what we have to do is we'll have to divide these marbles. For example, in this case, there are four marbles. Out of them, we have to divide in such a way that we are able to fill these two bags, but there are some constraints here. Okay. No bag should be empty. Okay. If the ith marble and the jth marble are in a bag, then please pay attention here. This is the most important part of this question. See, based on this question, so based on this point, the whole answer depends. Okay. So please pay attention here. If the ith marble and the jth marble are in a bag, then all marbles with an index between them, okay, should also be in the same bag. I will repeat. If the ith marble and jth marble are in a single bag, then all marbles with an in that is all the marbles in between them index wise should also be in the same bag. So that means all marbles starting from I plus 1 till j minus 1 should also be in the same bag. Okay. Now these 2 points are there. Okay, bag should not be empty, and then the marbles between two marbles should also be in the same bag. Now these are there, but now coming to the question where we are going to judge the answer, that is going to be by the score. Okay, the cost. If a bag contains all the marbles with an index I to j, okay, inclusively, then the cost of the bag is going to be weight of I plus weight of j. So remember, some things are very important here. That means only the border weights are important. For example, say I have weight till I starting from I till weight j, okay, inside a bag. Let us say the first bag, but I am not concerned about the rest of the weights. Okay, only the starting weight and only the ending weight. Okay, only these two are going to be of use to me. Rest of them are not used to me. Okay, they are not useful in our case. Okay, so this is the how we are calculating score. Okay, I will again repeat. We have k bags, we have n marbles. Okay, it's a zero index array. These are marble weights basically. Okay, what we have to do is we have to fill the k bags as that none of the bags are empty. Okay, suppose I have sent ith and the jth marble to a bag, then I should send all the marbles between them also to the same bag. Okay, then comes the way to calculate the score. How to calculate the score? For example, see in this case, suppose I have sent the ith marble to a bag, I have sent the jth marble to a bag, and all the marbles in between them also to the same bag. Then the score of that bag will be the weight of this marble and the weight of this marble. Okay, that is the marbles which are at the border. Okay, those one of the weight I have to take. Okay, so the score after distributing the marbles is the sum of the cost of all the k bags. Okay, so this is we saw what is the cost of a single bag. Okay, now they're talking about something called a score. The score after distributing the marbles is the sum of the cost. Okay, sum of the cost of all the k bags. Sum of the cost of all the k bags. Written the difference between the maximum and the minimum scores among marble distributions. So there are. I will go through examples first. I know this question is slightly weird to understand, but see, I have stressed on the parts which are really important. If you pay attention, if you like go behind the video and maybe like if needed, play the video much in a slower speed, definitely you will be getting to know what I'm talking about. Okay. I've tried as much as possible to stress on the important points. Okay, these are the ones which are defining the question. Please pay attention there to understand these points. Okay, here there are just here we are defining what a cost is. Here we are defining what is the score and how it is related to a cost. And here is the real question. Okay, I have to find the difference between the maximum and the minimum score. Okay. We're coming to the first example now. Here there are two bags. So basically there are two bags and all the marbles should be filled in these two bags. Okay, so we are doing a division here. Only the first marble will go to the first bag, and rest of the marbles will go to the second bag. Okay, and now if I have to calculate score, what will be? So the ith and the jth index for this is going to be the same. Okay, so what are their weights? Their weight is going to be 1 plus 1. Similarly, if I talk about this division, the weight, sorry, the cost of this particular bag is going to be the starting index and the ending index weight. Okay, so 3 plus 1. Okay, 3 plus 1. So this is going to be 4 and this is going to be 2. So the total, the total score. Okay, not the score. Basically, the total cost of this bag is going to be 4 plus 2, which is 6. Okay. Now come to another distribution where we are having 1 and 3 and 5 and 1. Okay. So the first bag will have 1 and 3. If you try to calculate the cost of this, it's going to be 1 plus 3. Similarly, for this, it's going to be 5 plus 1. Okay. All the border value should be added. Okay. For example, 3 plus 1 was added here. Similarly, 5 plus 1 will be added here. So basically, 4 plus 6, which is 10. Okay. So they are claiming that this is the minimum and this is the maximum. Okay, this is what they are claiming. 10 minus 6 equal to 4. It's going to be the difference between the maximum and the minimum scores for marble distributions. Okay. Coming to second example, there are only two things and case equal to. So we have two bags and only two marbles. So obviously there's going to be only one possible distribution. Okay. The only distribution possible is 1 and 3. Since both the maximum and the minimum scores are same, the answer is 0. Okay. The maximum minus minimum will be 0. You can see it is of the range 10 power 5. That means a brute force approach definitely won't be possible. And remember one thing, k is always going to be less than equal to width length. Okay, this is an important condition for us. So how to solve this? So one thing is very clear that see, for example, I have to find for example if this is the distribution 1 3 and 5. Okay, so only 1 and 5 are important to me. Okay, suppose 1 3 and 5 are my distribution, so only 1 and 5 are important to me. Okay, 3 is not at all important for me. Similarly, when as the length of the array grows, as we saw in the constraint, okay, it's a near 10 power 5. So only the border ones are going to be of use to me. The remaining ones are not of use to me. And we will see also in detail. Remember one thing, the score is basically the cost of all the k bags. Okay, not any bag with the highest sum or something like that, highest score or something like that. So all the bags cost will be included. Okay, let us see deep dive what we're happening. Okay, so suppose these are the weights. We can see how we are calculating the score. Basically, suppose 1 and 3 went to the same bag means the score will be 1 plus 3 and similarly 5 plus 1. Okay, suppose this only single thing went to a bag and this the rest 3 went to another bag, the score is going to be 1 plus 1 and 3 and plus 1. Okay, this is how the scores are being calculated. Then we will calculate similar scores for all possible distributions, and then we'll find out which is the maximum and which is the minimum. Then we'll subtract the two. Okay? Now, coming to the real part of the answer, you will see that for every, for example, if I have k bags, so basically I have to do k divisions. Okay, so for getting k sub arrays, please focus on my words. These words I am saying that after going through the question and after seeing all possible edge cases. Okay, so please pay attention. Definitely will answer. It will take much lesser time to understand if you see this video. Okay? So for getting k subarrays, that is for getting k divisions, I need k minus one splitting points. What it means is, see, for example, if k equal to 4, okay, so I have to make k subarrays because as you know, a bag cannot be empty, right? So definitely I have to take k consecutive subarrays. Okay, for example, the green one which you're seeing is a subarray, the red one which you're seeing is a subarray, this 5 is also a subarray, and these things in the skin color which you are seeing is also a subarray. So for getting, for getting to be, for getting 4 bags to be filled, I need 4 subarrays. For getting 4 subarrays, I need 4 minus 1, that is k minus 1 splitting points. Okay. So for getting these 4 bags, we have 3 splitting points. As you can see here, this is a single splitting point. This is a single splitting. Please follow my mouse pointer. This is a single splitting point, and this is also a single splitting point. Okay. So yeah. But how these things are contributing to the score. Okay, so see how to find the score now. Please pay attention, you will definitely get what I'm saying. See what I have to do, 0 plus 2. Okay, then 3 plus 4 is the going to be the cost of this, 5 plus 5, 6 and 8. Okay, so if you pay attention here what is happening, see suppose the k divisions are like this. See, the dividend is happening here, right? So I am suppose the dividend is happening at 2. I am calling it as x. Okay, x and x plus 1. Okay, both of them are going to contribute. Okay, so for example, if the division is on the first partition is stopping at 2, so the next index is also going to contribute for the next partition. Okay, so this I am calling as x, so this will be x plus 1. So similarly this is representing this image. Okay, so there are, suppose I have k bags, so definitely I will have k minus 1 splitting points. Okay, so suppose there are 4 bags, I will have 4 minus 1 is equal to 3 splitting points. Okay, so x, suppose I'm calling it as x, the next point will be x plus 1. Suppose I'm calling it the next splitting point as y, means the next point will be y plus 1 and so on. Okay. So what I'm trying to say is, see what are the things which are going to contribute to my answer. So what I will do here is the first plus the 2. Okay. what is 2? 2 is basically the x. Okay. Next, what I'm going to do, then x plus 1 I'm going to take. Okay, x plus 1 and this y. Okay, x plus 1 till y, then y plus 1 till z, and then z plus 1 till last. So one thing is very clear, please follow first to x plus 1 to y plus 1 to z plus 1 to last. Okay, so if you try to follow what we are taking, the max weight is, see, please follow this thing. Okay, first to x plus 1 to y plus 1 to z plus 1 to last. Okay, these all should be added, and this will form the score of a single distribution. Okay, so if you see in general what we're taking, always we are taking the last weight and the first weight. Okay, the first and the last weights are already taken, always taken, and we are trying to take k minus 1 values, sorry, k minus 1 pairs. See, these are the pairs, right? If you're seeing here, see, this whole thing is a pair. Okay, they are adjacent values and forming a pair. These are also adjacent values forming a pair. These are also adjacent values forming a pair. Okay, so if you try to understand this, what is happening is, see, always the first and the last value of the this thing. Okay, for example, 1 and 1, these two things are always taken. Okay, for calculating any score, these two values are always added. Okay, next, we are taking k minus 1 pairs such that they are contributing the maximum value. Okay, what is the maximum value, how can they contribute? Take any number. Okay, its addition number is 2. Suppose this is the number 1, its next number is 2. Okay, then 1 plus 2 should be contributing highest. Okay, so we have to take such, like for example here, 6 plus 1 7 is going to be much contributing much greater than 1 plus 2. Okay, that's what we are trying to understand. Okay, this is how they are contributing. So this is the sum. Okay, sum of the highest values, sorry, some of the, we are taking k minus 1 batch with the highest value. Okay, so how to calculate the minimum score? Same thing, the first weight and the last weight plus values of, sorry, the sum of k minus 1 batch which are, have a least sum. Okay, we understand that how we are taking. But yeah, I hope you have now understood what we are doing. Okay, the first, that is score for this whole array is going to be dependent on the first and the last element. Okay, 0 and 8. Then the value of these k minus 1 adjacent pairs. Okay, these are called pairs. Okay, x and x minus 1, these are called a single pair. Okay, so we are having k minus 1 adjacent pairs. That means 2 into k minus 1 total numbers. Okay, which are going to be added. Now comes the solution, how we are going to find such pairs. So what I'm taking is, for example, when I am talking about 0, I will add 0 plus 1 and I will store it in the pairs weight. Okay, similarly I will have, when I am come to 1, I will add 1 plus 2 and store it in s2. Similarly I will add 2 plus 3 and store it in s3, and so on. Okay, so what I'm doing is, the score is composed of weight 0, weight and till weight and so on. Okay, so among them I am going to take the highest weight. So please try to understand what I'm doing here. See, this image will convey everything. Okay, see, what is x? X we don't know, but we just know that x and x plus 1 should contribute to the maximum. That is 2. We have to take as elements as that the sum of that element and the next adjacent element should contribute to the maximum. How to find that? With that, we are going to do using this array. I'm going to make a separate array called pair weights. In that, what I will do, I will go through each element and I will store its sum with the next element sum. Okay, so 0 plus 1 will be stored here, 1 plus 2 will be stored here, and similarly 2 plus 3 will be stored next, and it will go on. Okay, it will go on. Okay, that's what we are going to do. Then once we get that, we'll sort it out so that the first k minus 1 values, will be the least, if we sort it in the ascending order, we'll see in the code, the first k minus 1 will be the least, significant values, and the last k minus 1 values will be contributing the highest. Okay, they are the most significant values. Then we can add these things. Okay, because see, these are common. Okay, if you subtract the max score and the minimum score, you will see that these things will get removed because they are common. Okay, if you subtract the max and the min score, you will see that we are basically having the sum. We are basically subtracting the sum of the, most contributing k minus 1 pairs minus the sum of the least contributing k minus 1 pairs. Okay, that's what we are doing. Let's come to the code first. So what we are doing, we collect and sort the values of all k minus 1 pairs. Okay, we are calculating the length first. Then we are making a pair. Okay, pair weights. We are making array of length n minus 1. Okay, why n minus 1? Because remember, if you have length, let us say 3, then you will have, see, if you have a length 2, then both will be stored in using a single. Okay, for example, when I talk of 0, I will be storing 0 plus 1 there. Okay, so for two things we need our single index. That's why the index of this will be, suppose there are n elements in this, so the it will be only n minus 1 elements. That's what I tried to convey. Okay, so pair weights will have length of n minus 1. Okay, initially all of them are 0. So I will now begin my, the traversal. It will be till, it will be from 0 to n minus 2. Okay, that is still the second last element. Okay, what I'm doing, I'm adding for every weight, I'm adding its next weight. Okay, and I'm storing in the ith index of it. Okay, I'm for every weight I'm adding its next weight, and I'm storing in the ith index of the pair weights array. Okay, after this is done, okay, I will sort it out. Okay, I will sort out in the ascending order. That means the first values will be the smallest one. That is the one which having the smallest this sum. Okay, then the last and minus that is the last values will be the one having the highest sum of this. Okay, so what I will do is I will take the first k minus one values and I will take the last k minus one values and I will do this. Okay, to get the max score minus the minimum score. Okay, so this is my answer. What I am doing. Remember, I want only k minus one values. Okay, the starting k minus one values and the last k minus one values. Okay, how to do that? That's what we're doing here. Okay. This part I think would have understood. Remember, we are sorting it in the ascending order. So the first k minus one values will be the smallest one. Okay. What we have to do, we have to subtract the the smallest from the largest. Okay. So these are the smallest values for every ith index, and the corresponding biggest value will be this. Okay. How we are getting this? Remember, this array has a length of n minus one. Okay. So what will be its last element's index? It will be n minus two. Okay. So this is what it is, n minus two and minus I. Okay. That means first it will be indicating to the last value, then it will indicate to the second last value, and so on. Okay. Similarly, this initially will be indicating the zeroth value, then it will go to the first value, and so on. Okay. So what we're doing, last element minus first element. That is the zeroth element. Similarly, the second last element minus the second element. That is the first index, and so on. Okay, this is how we are doing, and their sum is we are getting added in the answer. Okay, answer is initialized with zero, and we are adding the sums. See, this difference is happening here basically. Okay, so basically what it is, that is the last element. Okay, last element minus zeroth index element. Okay, zeroth index element plus second last element and the first index element and so on. Okay, like that it will continue. Okay, and like that it will continue. That's what it is. That's what we're doing. So as I mentioned, see for k values there are going to be k minus one splitting points. Because of k minus one splitting points, that is getting divided into k sub arrays. So that's what we're taking. We will be taking the first k minus one values and the last k minus one values. They may be overlapping, but still we'll take them. Okay, and this will contribute to the answer finally. So, in order to summarize what we have done, the answer here is see, this point defines that how to take the score. Okay, the score is basically going to be, for example, if I take in this subarray, okay, 0, 1, and 2, but the score is only being contributed from the first and the last value of the weight. Okay, so we are trying to understand, as we saw also, like if you see this, ultimately, if you subtract the min and the max score and the min score, basically this is like getting resolved to the pair values. Okay, the first k minus one biggest values and the minus the first k minus one smallest values. We have to maximize this subtraction. That's why we are taking the biggest minus the smallest. I hope you would have understood what we are talking about. The I understand this question is slightly on the higher side, but remember one thing. See these things. If you go through, you will definitely understand what we are talking about. See, as I mentioned, there are splitting points, right? There are splitting points. For example, if two is a splitting point, then three, let's say its next addition element will also be a starting point of some other subarray. Okay, that's why x and x plus one. Okay, such things we are going to collect. Okay, that's why we are having this array called pair weights, where zero and plus one both we are storing. Okay, these all are going to contribute for the you know for that particular distribution. They're going to contribute for the weight. Okay, for the max score, this is what they are going to contribute. Okay, the first and the last value and the pair weights. Okay, similarly the first and the last value and the pair weights. If you subtract the first and the last value are common, they will be ruled out. And for the first k minus, that is the biggest k minus one values minus the smallest k minus one values. Okay, I hope you have understood what we are talking about. This was on the higher side, and definitely I don't expect people to understand this in the first go. But see, my only aim is to at least understand to at least teach you something. For every question, you should at least know something new. That's what my idea is. See, there's no point solving hard question because even in companies like Amazon and fine companies, you will not get questions of the level of hard. Okay, you will get only the medium questions which are on the harder side. That's what I'm trying to tell you. So for every hard question, at least try to learn something new. Okay. So yeah, friends, I hope you have answered, and I will give you a solution also. Please go through it, and yeah, we'll see you tomorrow. Thanks a lot.